Hey everyone, and welcome back to the channel. I was supposed to be working on an anime diff part 2 video, but Mateo, also known as Leighton Vision, the creator of the Comfy UI IP Adapter node collection, released a massive update to the way IP Adapter is used in Comfy UI, as well as put out 2 fantastic tutorial videos explaining a little bit about how to make the most out of it. And so, of course, after messing around with the new nodes for a few too many hours, as well as watching his 2 fantastic tutorial videos, I had to put together a video with my own findings and experience. Although some of the things I am going to cover in this series of videos has been covered by Mateo, I'll also be covering some new grounds, re-explaining some things, as well as trying out a few new things that I learned building on what he showed us on his videos. So stay tuned because we're in for a fantastic ride. So without further ado, let's get plugged in. So to install it, it's incredibly easy. The simplest way to do it is to use the Comfy UI Manager. Go ahead and open it, go into Custom Nodes, and if you already have it installed, I suggest uninstalling it, restarting, which I've already done here. With that, you'll already have all of the necessary nodes updated and installed correctly. But there's a little bit more that we need to do to make sure that all of the models are in place. To get the rest of the components, you need to go over to the URL I've put in the description section below, github.com/cubic/comfyui IP adapter. It's all down below. And we need to now download all of these models into the respective folders. It's not that complicated, but it is a bit of a pain. Now, the way I do it is to make sure that everything is named correctly. The first thing I'll do is I will go ahead and select the model that I'm going to download. Press Ctrl-C so that I've copied the file name, or Command-C if you're on a Mac. Then I right-click it, save link as, and your file explorer should appear. Navigate to your Comfy UI folder. In this case, I've got it saved here in my history. Then go to Models, and then navigate to the respective folder for the model that you're trying to install. In this case, the first batch are in Comfy UI Models Clip Vision. You also need a Comfy UI Models IP adapter, and I think further down there is a Models LoRa's. So as you can see here, I already have Clip Vision from the previous version of IP adapter. I have LoRa's, as that comes with your Comfy UI installation, but I do not have IP adapter. So let's go ahead and create that. So in your file explorer, whether you're using Windows or you're using Mac, there should be a button to create a new folder. In this case, on Linux, I've got it up here, and I'm just going to create the IP adapter folder. And we can see here in the address bar, it's already been created, Comfy UI Models IP adapter. However, the first model that we're downloading, which is the Clip Vision one, is not the one that goes in IP adapter. So if we go back to the Clip Vision folder, you may or may not have some models already installed. I have these installed again from my previous uses of IP adapter. But if you don't have it installed, you'll see down here that the model is named model.safetensors. And that's why we copy and pasted the file name earlier. So we're going to go ahead and select that, and then press Ctrl-V, and then remove any white spaces and commas that we might have picked up. And that way you ensure that the file name is saved with the correct name. As you can see here on Linux, it's showing me that I already have the files. I'm not going to go ahead and press save, but this is where you'd press save and the file will download. Do the same for the second one. So we're going to go ahead and select it. Right click it, save link as, go to Comfy UI, Models, Clip Vision, and then paste the file name, removing white spaces and commas. So that's it for the Clip Vision folder. Now the rest of these need to go into the IP adapter folder, which we created earlier. So same thing, we're going to go ahead and copy the name. Now, I do believe that these already come named correctly. So let's see if that's the case. Save link as, Comfy UI, Models, IP adapter. So here, I don't have any of the models pre-installed, as these are specific to the new version of IP adapter that's been created. And fortunately, you can see down here that the files have the correct name. So we don't need to go and copy paste them. So I'm going to go ahead and save. And these models are pretty small. They're about 60 to 100 megabytes each. So downloading them should be a quick and easy process. And once you're done, you just want to go ahead and count through to make sure that you've got them all. In the IP adapter folder, you want to be having 10 models downloaded. I actually missed one, so I had to go back and check and download the one that I missed. So make sure you count and check. Now, if we scroll down the installation instructions, it says something here about requiring Inside Face. We'll come back to that later. For now, let's finish downloading the remaining IP adapter models. Now, these ones over here are specific to Face ID. So if you're not going to be using Face ID, you don't need to install it, but if you are, go ahead and download them just like you did the ones before and put them in your IP adapter folder. And once again, don't forget to count the number of models. In this case, you should have 6 with the name Face ID in them. And then finally, we have the last 4 models that we need to put into the LoRa's folder. So let's go ahead and do that. And that should be 4 into the LoRa's folder. Now, in addition to that, there are a couple of community IP adapter models that have been listed here, which you can go ahead and try out. One is great for composition, and one is an alternative to the SDXL version. So download them, try them out, and see which one works better for you. Note that the composition one is for Stable Diffusion 1.5. Now we're almost finished. There's just one more thing that we have to do. If you remember a little bit earlier, there was a section here that required Insight Face, which is required for some of the Face IP adapters. Now to install that, there's just one little modification that we need to do. And you might even already have it installed. To check if you have Insight Face already installed, go into your Comfy UI folder, go into Models, and see if you have an Insight Face and X folder. If you do, that means that you probably have another node that's using Insight Face and ONNX, in which case you shouldn't have to do anything. If you don't have those folders, however, all you need to do is go to your Comfy UI base folder, look for the file called requirements.txt, open it with your favorite text editor, and just add to the bottom Insight Face and ONNX. Press Ctrl S or save, and then if you have Comfy UI running, please go ahead and quit out of it. Make sure your terminal is in your Comfy UI folder, and then you're just going to type in install-r requirements.txt and press enter. And what that's going to do is it will just add on the Insight Face and ONNX modules to your Comfy UI installation. That's it. That's all you got to do. Once you're done, go ahead and start up Comfy UI once again, and you're ready to go. Insight Face IP adapter is already installed. Great, now that we've set up and installed the necessary models, let's have a look at what a basic workflow looks like. So the key elements that we've introduced here for the IP adapter version 2 is we've added in the unified loader and the IP adapter node. And Mateo's done a really fantastic job of simplifying this for us so that if you want to get up and running quickly with IP adapter, you can do so with a very, very small amount of fiddling. So the unified loader accepts the model, which comes from your checkpoint loader. And although there is a IP adapter input here, if this is the first or only unified loader that you're using, you can leave that blank. That will come in handy with daisy chaining, which we'll explore later in the video. Then you output the model and the IP adapter into the IP adapter node, along with the image that you're using as a reference. In this case, it's not loading here, but you can see it over here. This is the image that we're using as a reference. You can set the necessary weights along with the weight type. In this case, if you're just using the basic version of the IP adapter, the options available are standard, prompt is more important, and style transfer, and again, we'll explore these later. Additionally, on the unified loader, you can select the IP adapter model that you want to use. In this case, because we are trying to use the same face, we are using the plus face model. And you'll note that there are different ones here. There's standard, VIT-G for medium strength, plus for high strength, plus face, which is for face, and then a couple of 1.5 models. And if we go ahead and generate, we can see that it does a pretty good job of transferring the likeness of the face over. And we can further improve on this by actually combining the Face Plus model along with the Face ID model, which again we'll cover later. And that's pretty much all you need to get started. But there's a lot more you can do with the IP adapter changes that Mateo has done. However, now that we understand the basic workflow, we can start to explore what are the different ways that we can modify it to get more out of it. Let's start with the unified loader. So as I explained earlier, the unified loader combined with the IP adapter node is the basics that you need to get up and running in a quick and easy manner. Aside from the unified loader, there's also a version of it called the Unified Loader Face ID. And this one does exactly the same thing, except that it uses the Face ID models. Like in the vanilla unified loader, we can open it up and grab Face ID Plus version 2, and Face ID Portrait. Typically though, you want to just use Face ID plus version 2 as that is the better model. And again, I'll show you later, we can actually combine these so that you're actually using Face ID plus V2 and plus Face. Both of these feed into the IP adapter, like so, along with the reference image. Now, if we want to have more control over what models the IP adapter is using and how it's applying itself to the reference images, that's where the advanced nodes come in. So aside from the IP adapter, we also have the IP adapter advanced node. And again, this does the same thing. It accepts the model and IP adapter as well as a reference image. Additionally, in the advanced node, you can also accept an image negative, which allows you to provide an image as a negative conditioning, just like you would do with text. A great way to use this is, for example, if your image is showing too many painted artifacts or painted styles, you can use a painting as a image negative, or the image is appearing with artifacts or white dots. These usually indicate that the image is burned. So you can feed in a image negative of just noise to tell the K-sampler that you don't want noise in the final image. And again, we'll look at this a little bit later. Additionally, you can also select which clip vision you will be using. In which case here, we have the load clip vision node, where if you installed it, as I explained earlier, you'll have a few options here on which clip vision you want to use. Typically, it'll be VidH or Big G. So we can go ahead and wire that in. If you're using the regular IP adapter one, this still happens, but it's just taken care of for you. The IP adapter advanced node also has some additional parameters that we can modify that give us a little more control on how the reference image is applied. The main and most important one is the weight type. And you'll see here, this gives us a lot more options than in the vanilla IP adapter. If we look again down here, the vanilla IP adapter just gave a standard prompt and style transfer. Whereas on the advanced, we have linear, ease in, ease out, reverse in, out, etc., etc. Now, if you're wondering what these are different ways that the reference image is applied to the model. To better understand that, typically a Stable Diffusion image model uses what's called a U-Net model, which can be illustrated like this, where you have the input image file, and that goes through a process, through inference. I'm honestly not very familiar with the particulars of this, but what I do understand is typically the way the models work is they accept a series of inputs, which in this case would typically be the noise and the conditioning that we provide, and encode that data by downsampling and then upsampling while reducing the noise. And this is extremely oversimplified, but just for the purposes of this video. So when we select different weight types, what we're doing is we are telling the model to apply our conditioning differently throughout the process. So with linear, the conditioning is applied evenly at each step of the U-Net model. If we do ease in, then the conditioning is applied more aggressively at the beginning of the model, and then it reduces the amount of conditioning throughout the model. So that means that with an ease in weight type, the IP adapter information is front loaded, and then everything else that happens in the model happens naturally as the process moves on. Ease out is the same thing, where the IP adapter information is loaded in at the back, so it will generate everything first and kind of start to apply the features from the IP adapter towards the end of the model, or the end of the generation. Ease in, ease out, and strong middle are kind of the same thing, where the IP adapter applies the conditioning very strongly around the middle. Reverse in, out, and weak middle are more or less the same. And weak input, weak output are similar to ease in and ease out. If you're not getting good results, you'll need to experiment a little bit with the different weight types to see what gives you the best results. And if you're trying to decide which weight type to use, I've actually prepared a little utility workflow to help you figure out which is the best weight type to use for your reference image. So as you can see here, it's a bit of a mess, and I will be making a cleaned up version of this available to my patrons. With this workflow, you can put in your reference image and it will run through all of the K-samplers and all of the IP adapters, with each one applying a different weight type, and you can compare the results here. This is especially great when deciding whether an image is workable or not, because you can see how the different weight types provide an output and help you decide if you need to use a different image, as well as which weight type to use when developing your workflow. What's especially fascinating here is how some of the weight types have taken the hair color and applied it to the dress. We can see here in ease in, weak output, strong middle, reverse in out, they all have a blue dress, while the remaining of them all have a pink dress. What's also really fascinating is to see how well the facial features have been maintained in the different versions. And like I said earlier, if you want access to this, it's available to my Patreon. So come on down to the Patreon and check it out. Before moving on, there is one more thing that I do want to mention, which is quite important, which Matteo raised in his workshop, is you'll see here when I load the image, I actually pass it through this prep image for Clip Vision. Now, this is not necessary, but it is very helpful even if you are using a square image. So the purpose for this is if you are uploading an image that is not squared, it will crop the image into a square because that's what IP Adapter likes. But even if you are providing a square image, it's recommended to use this because of the interpolation method. To use the image with IP Adapter, the image gets downsampled, which means shrunk, and the standard form or the standard way that it gets done is by cubic, whereas using Lanczos can often provide better results. So that's one of the reasons to use prep image for Clip Vision. But again, it's worth experimenting with different interpolation methods with and without the prep image for Clip Vision to see if you get better results, particularly when using the face models. Now, one of the cool things that we can do with IP Adapter is we can take a picture with a article of clothing. In this case, we've got this dress, and this typically works better if you don't have a person in the reference image, but in this case, we're going to try one with a person already in it. And if we plug it in as a reference image, we've prepped it here and then fed it into the IP adapter. We're going to change our preset to the +1. And if we go ahead and queue up the prompt, which you'll see here says woman wearing dress, blue eyes, and so on, we can see that the dress has been passed over to the new image. Now, because the reference image has a person in it and we're using the +style IP adapter, it's taken it a little too aggressively. So we can refine that a little bit further by dropping the strength. So let's drop the strength down to 80 and emphasize in our prompt that we want to see the full body. We specified blue eyes, so hopefully that will encourage us to see the eyes. And let's give that another prompt. If we're still having a difficulty moving away from the framing of the original image, one of the things that we can do is switch out the IP adapter model. Yeah, so it's slightly better. We're seeing a little bit more, but it's still focusing a little too aggressively on the same shape that we've given. So let's try the standard model. And this is the thing with the IP adapter. Once you understand it, it takes a little bit of experimenting to figure out what are the right parameters for what it is that you're trying to achieve. There we go. So because we've used a less stronger model, the general concept of the dress is there, but there are some changes. It's a little bit more blue. The design is slightly different, but for the most part, we have been able to transfer over that style. And like I said, this works much better if you do not have a model in the reference image. But let's take this a step further. Earlier, I showed you how we had a reference person and we were able to create new images from that. Now, what if we want to combine the outfit and the reference person that we had earlier? So let's go back and reattach the person to the process. And I've got the dress here attached to a new prep image for Clip Vision. And what we can do is we can come back here to where we've got our IP adapter section. And by the way, the original version of this workflow will be available to everyone. Links will be down in the description below. So let's go ahead and grab the IP adapter unified loader. And then we're going to press Control or Command C and then Command Shift V or Control Shift V if you're on Windows. And that will create a copy with the existing connectors already there. And instead of using the IP adapter, we're going to try the advanced IP adapter this time. And then we're going to plug in the model and the IP adapter. Now, a couple of important things to note here. We're now using two sets of IP adapter nodes, and we want them to work together with the same K-sampler. So the way that we're going to hook that up is, as a reminder, we now have the original checkpoint connected to the original IP adapter unified loader and the new one. I actually made a mistake and it should not be there. What we're instead going to do is the original IP adapter, the one with the full face, that plugs into IP adapter, and then IP adapter is going to feed the model into the new IP adapter unified loader, which then goes into the IP adapter advanced, and then we'll take it from this model down into the K-sampler. So now the K-sampler is connected. The other thing that we need to do, and this is really important, especially if you are using a less powerful GPU, is take the IP adapter from unified loader and connect it up to the new IP adapter unified loader. And the reason that we're doing that is every time you have a unified loader, it actually loads up all the models. So everything here is actually loaded. Now, if you have the two IP adapters not connected via the IP adapter node, it will load the models twice. What we're doing here by connecting these two IP adapters is when this node loads up the models, the second node can take advantage of that and use the models that are already loaded. So it just streamlines our resources. So now that we've got the second set of IP adapter nodes set up, we just need to attach the reference image. So in this case, the dress, once it's prepped, we feed it into image. So let's go over this one more time before we queue it up. So these two sets of nodes are working on the face, and these two are working on the dress. And together, they should create a character that is wearing a dress that more or less looks like the reference dress and the reference character. And we've taken the advanced one, as we're not familiar with the different weight types, we can mess around with them to try and get a better result. So this is our reference character, and cha-cha! We now have our person or our character wearing a outfit that looks very similar to the one that we provided as a reference image. Now, this can be further fine-tuned again by messing with the weights, messing with the weight types, tweaking the prompts. As you can see, we are continuing to inject blue into this. If we have a look at the workflow that we set up as a reference, we can see that linear, ease in, ease out, and weak input had a different colored dress. So if we look, we can see here that ease in, ease out, reverse in, out, and weak output all had a blue dress, which indicates that it was taking the conditioning a little bit more strongly. Why don't we try applying one of these to the dress one? So I quite like the ease out one. So let's try that with the dress, right? And it's really interesting because if we switch out the IP adapter that we're using for the face reference, we can combine different weight types. So again, using this as a reference, we can see how with the weight type applies it differently. We could try ease out for the dress and ease in for the character face. And we can see, interestingly, the character just look a little bit better when applying that weight type through the dress, but the dress changes completely. We tried this ease out one, or why don't we try ease in and out, since that has a different dress color. And we'll see what that does to the dress, and then we'll add in the advanced IP adapter to the face reference. So interestingly, we can see that with the ease in, ease out, the dress once again looks a lot closer to that of the reference image. Now let's go ahead and swap out the IP adapter for the advanced one. Copy, paste that. Connect everything up the same. So model to model, IP adapter to IP adapter, the output model to the second unified loader, and then reconnect the reference image. So for the dress, we tried ease in, ease out. Let's try ease in, ease out with the person as well. So interestingly, while the facial structure is right, there are a few weird things going on with her face. If we go back to the toolkit that we made earlier, let's actually try ease out. As I had said earlier, I really like the facial structure in that one. And there we go. The face actually looks a lot better, and this will probably look better when it gets upscaled. Now, before we finish up, I want to touch on attention masks and leave you guys with a cool little trick that you guys can do with it. So you might have noticed in the reference images here that the colors of the dress are always pink or blue. The reason for that may have something to do with the original reference image, which is this one over here. And you'll notice the two predominant colors are pink and blue. So attention masks can be a way to remove elements from a reference image that could be distracting the model. So in this case, what we're going to do is we're going to take the image that we've loaded, which should appear here, but like I said, it's a little buggy. So we're going to go ahead and right-click it and open it in the mask editor. Sorry, I had to rename it to get it to appear on the editor. And what we're going to do is we're going to go ahead and just mask out the face. And for this example, you'll notice I'm barely grabbing any of the hair. So let's go ahead and save it to Node. And what we're going to do is we're going to feed mask into attention mask. Again, for the purposes of this illustration, we're just going to feed it into the IP adapter marked as linear so we can compare it with the other ones. And we can see by using the attention mask how not only the color of the dress has changed, but the background, and even if we look at the hair, it's just the front that is colored blue, whereas the rest of it has gone this brown color. So attention masks can be a really powerful way to bring attention to the IP adapter to the areas that you want it to focus on, while removing things that are causing distractions or sending the model in the wrong direction. So with that information, here is a really cool thing that we can do with attention mask and the style transfer weight type on the advanced IP adapter. First, let's test out the style transfer weight type with our existing image. So let's rename this one to that one so we can see the reference image. Let's grab the dress and hook that up as well. So now that we have the workflow that we used earlier to create our character, Marina, wearing the dress that we chose, let's try and apply a style to her. So we're going to go ahead and grab another load image node, and let's load up an image with a really cool style. I found this one online with this really cool retro neon style look, so we're going to go for that. Like before, let's grab another unified loader and another IP adapter advanced. We'll wire them up, feed the output of the last IP advanced adapter into the new unified loader, daisy chain the IP adapter, and this time we're going to change the weight type to style transfer. And let's feed in the new advanced IP adapter into the K-sampler. Sorry, and I forgot the reference image. So let's bring that in. And we can see that it's applied that retro neon style to the image and possibly tried to give our character glasses. Let's just see what it does if we use the VitG medium strength. I found that worked better for the dress as well. There we go. We don't have that whole glasses thing going on here. So now we've got this really stylized image. What we're going to do is we're actually going to apply two styles to the image to different parts. And this is how we're going to do that. So we've got one here. Let's go ahead and grab those three nodes and duplicate them using Control-C or Command-C and Command-Shift-V. Okay, and we just need to make some adjustments. So again, daisy chain the IP adapter. Those are connected correctly. Feed in the end of that model into there. And then feed in the new model to the K-sampler. And this is where we're going to have fun with the attention masks that I explained earlier. So we're going to right click the first image and open it in the mask editor. Let's grab a nice thick brush and we're going to mask out half the image. And we're going to save that to node. And for this node, we're going to go in and actually grab this grungy image that I prepared earlier. Something really contrasting. And then what we're going to do is we're going to grab the mask from the original one and we're going to apply a Gaussian blur. And then we're going to invert it. And now that we've done that, what we're going to do is feed the original mask of the neon image as an attention mask to the IP adapter that is using that image. And then we're going to feed the inversion, which basically is going to flip the mask over with the Gaussian blur applied and send that into the IP adapter that is referencing the grungy image. And then we're going to queue that up. And now we have this really cool dual tone image with the two styles applied to it. So you can feel free to get really fun and artsy with that. So if we look at the way the image is set up here, we can tweak the mask slightly. So if we go back to the style and open that up in the mask editor again, let's say we want to include the face of the character in the mask. We kind of know that it's in this area over here. We'll just drag in a little bit more. And what's cool, because of the Gaussian blur, it blends really well from one into the other. And remember, these are not just regular masks, they're attention masks. So you'll notice that by tweaking the mask slightly, the character herself has also changed. So it's not just a mask of where we're applying the style, but where we're bringing attention to. And that, of course, affects the conditioning that goes into the model. So I'll just finish up with this slightly more aggressive one. And as you can see, you could just spend hours having fun with this. There are so many creative ways that you can take advantage of these nodes and the way that they've been set up. So what did you guys think? Pretty cool, huh? If you found this helpful, please don't forget to like and subscribe. And if you want access to the toolkit workflow I showed earlier, as well as advanced versions of the workflows that I provided with upscaling, as well as a few other experiments that I've been running with IP Adapter, please come by and check out the Patreon, as these workflows are exclusively available to patrons. For everyone else though, I do have the basic version of the workflow as well as a few variants available on my website, so please head on over to check those out. I also invite you to come by our Discord where we can chat about different workflows, help you troubleshoot any problems that you might be having, as well as discuss other AI-related matters like large language models and Silly Tavern, which we also cover on this channel. I also wanted to take a minute to thank all of the patrons who have supported me so far. It's thanks to you that I'm able to continue making these videos, and your support means a lot. As usual, links are all down in the description below, and I'll catch you guys in the next one.